Okay, today's lesson is on 6.1, roots and radical expressions. So we've talked, or you've heard a lot about square roots, and now we're going to continue on with things like cube roots and fourth roots and fifth roots. Okay, so when I say 3 to the second power equals 9, that means 3 is a square root of 9 because 3 times itself gives you 9, or better, 3 to the second power gives you 9. Okay, 3 to the third power is 27. That means 3 is a cube root of 27 because 3 times itself gives you 27, or 3 to that third power is 27. 3 is a fourth root if 3 to the fourth power would give you 81. 3 is a fifth root of 243 because 3 to the fifth power gives you 243. Okay, so for any problem in this form, okay, each of our problems, examples above, had 3 as that base. Raised to an exponent gives you some number. We're calling that b. Okay, so that number inside of a radical would give you your base if that little number, which we are going to call the index, tells you, the index is telling you what power you should be raising a to get the number inside of your radical. So my square root symbol, I'm referring to as a radical symbol because it is going to show up as not just a square root from now on. Okay, so we can rewrite 3 to the fourth power as the fourth root of 81 equals 3. So you'll see little numbers here. If there's no little number there, it's assumed it's a square root like it's always been, but you'll start to see those numbers. Okay, so some examples here. You might see things that would say, find all the real, for number 1, all the real square roots of 9. Okay, so that means there are 2 things that make that true because both positive 3 and negative 3, when you square them, you get 9. Okay, if you are just given the square root of 9, that's assumed that you just want the positive answer. That is the positive or principal root. So that means the answer is just 3. Okay, if there's a negative inside of your radical, there is no real root. The imaginary root 3i we talked about in our previous unit last quarter, they won't ask you to put it in an imaginary form. You'll just select no real root. Okay, I should put another example on here. If it said the negative square root of 9, the answer would be negative 3 because you're taking the square root of 9 to get 3, and that negative 1 would be multiplying the value that you get from the root. Okay, if it says all real, so in a sentence form, that's the only time it's asking for both. When you have the symbol, you're looking for, did they have a plus or minus sign on the outside? Because that's going to tell me what sign I use. Or is there a sign on the inside? Now it doesn't make it work. So now there is no real root, so you'll need to pay attention to that. And then if I have the cube root of 8, I'm looking for something times itself 3 times, or something to the third power gives me 8, and 2 to the third power is 8. So the answer is 2. Something that's interesting now when I look at example 5, the cube root of negative 8 does have a real root, okay? Because when I have something like a square root, there's nothing times itself that gives you negative 9, because when you take a negative times a negative, it would turn out positive. But we are taking a negative times itself 3 times, so that's going to make it negative. When I take negative 2 times negative 2 times negative 2, I'd get a negative 8. So the cube root of negative 8 is negative 2. So what we're going to find out is that our even roots can't have real roots if they're negative, but my odd can. All right, so we'll look at some examples here. Most of these are pretty quick, okay? You can try some things on your calculator if it's not coming to you right away, but make sure you're paying attention to your little index here is telling you what root, or it's telling me there's going to be some value to the third power that gives me negative 27. Okay, so you can take some things on your calculator. So I'd be using a calculator with exponents, and I'd test, 2 to the third, 3 to the third, 4 to the third. What does it give you? Do you get 27? We will need to have a negative number inside of here. But what you should find is that negative 3, when you raise it to the third power, it gives you negative 27. So then the cube root of negative 27 is negative 3. Do not put an exponent on that. The exponent helps you figure out what number is the answer. Okay, so when I look at number 2, if you have any problems with decimals, think of it as the cube root of 8 first. Okay, so what to the third power gives you 8? Well, that would be 2. 2 times 2 times 2 would give me 8. And then you can kind of check it with a decimal. So put a 0.2. Raise that to the third power, you will find that you get 0.008. So it would be 0.2. Okay, typically when they have a decimal inside of one of your radicals, you can just ignore all the zeros, use your number, find what value raised to that power would give you that number, and you put a decimal in front of it, and that's typically it. But you can check it with your calculator too. Okay, the fourth root of 81 means I'm looking for what number raised to the fourth power would give me 81. Okay, try some things out. It's a little bit of guessing and checking, but it really should not take you long. Okay, 2 to the fourth power is 16. 3 to the fourth power is 81. I'm done. If you tried something like 5 to the fourth power, you'd realize it got big too fast. Okay, so it shouldn't take you long to come up with these. Eventually, it would be nice if we're familiar with quite a few of them. You'll see that in the next couple lessons after this. So I want you to try it out today and practice figuring out how you get those numbers. And it'll make things easier that we do later on the week. Okay. With 4 and 5, both of those are in a fraction form. So you can separate them and take the square root of each individually. So there's no number here. You can write a little 2 if you want, but you never knew that there needed to be a number next to it to be a square root. So not necessary. So the square root of 4 is 2. The square root of 25 is 5. So 2/5 would be my answer. Okay. Same way with 5. My example 5, I'm doing now a fifth root of negative 1 divided by a fifth root of 32. Okay, so I'm looking for what to the fifth power gives me negative 1 and what to the fifth power would give me 32. Okay, some students I think get nervous kind of with the bigger number for that index, and I think it's going to get harder. It really should get easier, because when I'm raising things to the fifth power, it gets big really fast. I shouldn't have to try many things. So negative 1 to the fifth power is what would go on top. This is an odd root, so it's okay that it's negative, because I'm going to be taking negative 1 times itself 5 times, so it will be a negative number. And then 2 to the fifth, you'll find if you check that on your calculator, it gives you 32. Okay, for number 6, I'm looking for what to the fourth power would give me a negative 81. Now, negative 3 to the fourth power is not negative 81. That would be positive 81. And positive 3 to the fourth power is positive 81. So there is no real root. It would be an imaginary, okay? But it's not asking for us to find the imaginary, unfortunately. I know you're disappointed, okay? So if my index is even, I cannot have a negative in the radical to have a real root. So square roots, fourth roots, sixth roots, We won't really see eighth roots, but they're a thing, okay? All right, for number 7. So I have another decimal again. So go ahead and just take that 243. Figure out what to the 5th power gives you 243. Then we'll try that number with a decimal in front. So check on your calculator. This is a hard one to kind of do a virtual lesson with, because usually I just walk around and have students try things out and be like, all right, what'd you try? What'd you get? But when I just tell you the answer, it's just, and you sit there and watch, it's not as beneficial. So right now you're trying things on your calculator. You're taking something to the 5th power, okay? For the 5th power, it'll be too big. To the 5th power, that's 32, not big enough. 3 to the 5th power, 243, that'll work. So I put 3. If you try 0.3 to the 5th power, that will give you that 0.00243, sorry. Okay. With number 8, I'm taking the cube root of 125 and the cube root of 216. So I can do those separately, and I'm looking for then what to the 3rd power, cube root gives me 125. What to the 3rd power gives me 216. Okay, so you're testing that on your calculator. 2 to the 3rd is 8, not big enough. 3 to the 3rd is 27. Okay, 4 to the 3rd, 64. 5 to the 3rd is 125. So that means 5 would go on top. And then when I do 6 to the 3rd, I get 216. So 6 would go in the bottom. Okay. Last one over here, I'm looking at what to the 4th power gives me 625. Okay. So you shouldn't have to take long to try things. If you're trying really big numbers, you're going to find out it gets big really fast. Okay. This would be 5 to the 4th. So the 4th root of 625 is 5. What times itself 4 times gives you 625? 5. Okay. All right. So you'll have ones that are just straight numbers. Okay. But we're in algebra, so we're going to throw in some variables. Okay. So we're going to simplify these radicals. Use absolute values when necessary. Okay. So I'll talk about what that is. If the problem does not say assume all variables are positive, you must use absolute values. And that's most of the problems in this homework assignment. They start to say tomorrow and the next day, they'll tell you that you can assume they're positive and you can ignore and not have to do anything with absolute values. But all the ones I believe in your homework, if I remember when I looked at it, want you to use absolute values. So we use those when you start out with an even index, but once you take the root, it is an odd exponent. Okay, so for my first example, square root of 4x squared. So you're looking for what times itself gives you 4x squared. Well, the square root of 4 is 2. The square root of x squared is x. When I take 2x times 2x, I would get 4x squared. So hopefully that makes sense. We're trying to start simple here, but I need to include absolute values. If it didn't tell me, assume all the variables are positive. Okay, so I started out with a square root that is an even index, and the variable came out with an odd exponent. So starts with an even, ends with an odd exponent. So I need absolute values around the x. Otherwise, it's going to be marked wrong in Math Excel. Okay. Why would we care? If you only plugged in positive numbers, it wouldn't matter. So that's what the assume all variables are positive means. If you used a negative number, because when I'm simplifying this, any number I plug in to the square root of 4x squared has to give me the same value as 2x. Okay. If I don't use absolute values, it would only be true for half of the numbers you're going to plug in. because the other half of our numbers are negative. So for example, if I said x is -2, and I plug it in here, 4 times -2 squared in the square root. -2 squared is 4. 4 times 4 would be the square root of 16, so I get 4. Okay, if I did not use absolute values, I'd be taking 2 times -2, and I get a -4. When I plug it into the original, I get a +4. So I'm not getting the same value. So then I can't simplify them and say they'd be the same thing. But the absolute value would make that -2 a +2, and now I'm taking 2 times 2 to get 4. Okay, so that is the reasoning behind the absolute values. Just gonna get those out of the way. Okay, when I look at example 2, I have an odd index. I don't have to worry about any absolute values. Phew, okay, but I'm going to be thinking about, I'm taking each of these individual bases with their exponents, and I'm looking for, well, what to the third power gives me a to the 6th? And what to the third power gives me b to the 9th? So we're going to bring in our exponent rules we were talking about. And I'm looking at, well, A, I'm going to need to find some power, and B, I'll need to find a power here. So what do I do when I raise a power to another power to get 6? That means I have to multiply those exponents. So what times 3 gives me 6? Well, that would be 2. For the one below, what times 3 gives me 9? Well, that would be 3. So that means the cube root of a to the 6th is a to the 2nd. And the cube root of b to the 9th is b to the 3rd. Because a to the 2nd times a to the 2nd times a to the 2nd, you hear what I'm saying? Times itself 3 times does give me a to the 6th. You can add those exponents, right? B to the 3rd times itself 3 times does give me b to the 9th. We didn't have to worry about absolute values because I had an odd index. Okay, number 3. All right, I have an even index, so I might have to worry about it. So we'll keep that in mind. Maybe just throw absolute values on the side, or I don't know what you want to do. Make a note before you're done. Okay, I'm dealing with the 4th root, so be very careful with this, because I have a lot of students that want to take the square root of 16, they'll say it's 4. But I'm taking the 4th root, so that means what to the 4th power gives me 16, and also what to the 4th power gives me x to the 16th. Okay. Well, 2 to the 4th power gives you 16. So my answer will have a 2. And then I have an x. I'll have to figure out what exponent would make this true. Remember, you must multiply your exponents. What times 4 gives you 16 would be 4. So this is 2x to the 4th. Okay. Since 4 came out as an even power, I don't need to throw in absolute values, even though we started with an even root, because no matter what, I'm going to get a positive value whether I plug in negative numbers or positive numbers. Okay. Let's see if you understand. So I'll have you try these next 6 examples. I would suggest pausing the video, see if you get it, see if you can get your answers correct. These you will throw in absolute values when necessary. So I'll go over them now. So I'm taking the square root of 1 over the square root of 100x squared. Square root of 1 is 1. Square root of 100 is 10. Square root of x squared would be x. This is a square root, so that is an even index. and x is to the first power, so that is an odd power, so I will need absolute values because it doesn't say assume all variables are positive. Okay, for number 5, I'm looking for what to the 4th power gives me x to the 20th, and what to the 4th power gives me y to the 8th. If you haven't figured out just from your exponent rules, you're figuring out what times 4 gives me 20. You can absolutely take 20 divided by 4 to get 5 because that's just the reverse thought of what times something gives you this number. Well, I can take 20 divided by 4 and I will get the exponent. That does work. Okay, well, y to the 2nd raised to the 4th power give me y to the 8th because 2 times 4 gives me 8, or 8 divided by 4 would be 2. Okay, here I had an even root, so I must use absolute values around the exponent that was odd. Okay, for number 6, throwing in something just a little bit more, I don't know, interesting, I guess. So you're looking for, I don't know if this is a good way to write, what to the 3rd power gives you x plus 3 to the 3rd power? Well, that would be x plus 3. I had an odd index, so I'm not going to have to worry about absolute values for this problem. Okay. And then you're looking for what to the 6th power gives you x minus 4, to the 6th power. What to the 3rd power? Well, if my base is x minus 4, you're going to need an x minus 4. You're just figuring out what exponent goes on x minus 4. Well, that would be a 2, because 2 times 3. Okay, you don't actually need to square it. We are going to actually like things in that form later on, so we'll just get used to using that. If you did square it, remember you must take it times itself, so don't write that as x squared plus 16, because that would be wrong. We should get x squared minus 8x plus 16, but you do not need to distribute it out. But it's just a reminder, because I will have students that will think they distribute it correctly, but they don't. Okay. With number 7, you're looking for what to the 4th power gives you 2,401. That would be 7. What to the 4th power gives you x to the 12th? That would be x to the 3rd. So we got 7, x to the 3rd. I started out with an even root, so then I have an odd power. I'm going to need absolute values around that variable with the odd power. All right, then our last 2 examples here. So I'm looking for what to the 3rd power gives me a to the 6th. What to the 3rd power gives me b to the 6th. What to the 3rd power gives me c to the 3rd. Some of you can do this in your head. It's totally fine. But this is what's happening in my head. This is what I'm thinking about. Well, this is going to be a to the 2nd, because 2 times 3 gives me 6. So a to the 2nd. And b to the 2nd, because 2 times 3 gives me 6. So b to the 2nd, make sure they're all in the same location that they were, where they were in the radical. The cube root of c to the 3rd would be c. C to the 3rd is c to the 3rd. So then I have a c. I do not need to worry about absolute values. 3 as my index was odd. Also with 9, 3, I have an odd index. I don't need to worry about absolute values. Okay, I'm looking for what to the 3rd power gives me 27. I'm looking for what to the 3rd power gives me z to the 3rd. I'm looking for what to the 3rd power gives me z plus 12 to the 6th power. Okay, 3 to the 3rd is 27, so 3 will go on top. Z to the 3rd is z to the 3rd, so z will also be on top. And I got to keep my z plus 12, but figure out what exponent would be a 2, because 2 times 3 would give you 6. So z plus 12 to the second power. Remember, you can leave it in that form. If you want to distribute it, go for it, but please distribute it correctly. Please take z plus 12 times z plus 12. That would not give you z squared plus 144. You would get z squared plus 24z plus 144. Okay, but you don't need to do that. You can leave it in the form that it is in. So we're going to do more things with that form later on. All right, that is our lesson. Please let me know if you have questions. They're kind of quick problems, so it shouldn't take you a long time to do. If it's taking you a long time to do, you're probably not understanding. So please reach out and good luck with your homework. Bye.